Have I ever told you that my favorite movie of all time is Transformations? You thought I was going to say Transformers, didn't you? Though that is a good movie, not where I'm going with this. And actually, you know what? Transformers doesn't really have anything to do with this topic at all. This topic is transformations. And today we're going to focus specifically on a specific type of transformations called translations. Now, just to give you a little bit of an overview for this week, a geometrical transformation is any turn, flip, or slide of a figure. So down here below, we've got three examples of all three of those transformations. This would be a turn, kind of like you're turning a car. This would be a flip, so we're kind of drawing out the mirror image of it. And this one over here would be a slide. We're taking our original object and just sliding it over to a new location. So today we're just going to focus on slides. And then tomorrow and Wednesday, we're going to focus in on turns and flips. By the end of Wednesday, you'll know about all three of these. And then on Thursday, we can put them all together. And I've got a fun little game for you to play using transformations. Like I said, today your learning goal is that you should be able to translate or slide a shape from one location to another. Now, translate is just a fancy mathematical term that means the exact same thing as slide. So don't get confused between those two different terms, which you will hear throughout today's lesson. Okay, so let's have a look specifically at translations. This is a pretty wordy definition, so just listen up for the next 10 seconds as I go through this, and then we'll have a look down here at the bottom for kind of a more concrete example. So a translation is when every point of the original object moves the exact same distance and direction to form a new image. The resulting image will have the exact same size, shape, and orientation as the original. It'll just have a new location. All right, so kind of dissecting what I just explained there is if we have a look, the instructions for this question are to translate the original object, that's this purple one down here, translate it 2 units right and 4 units up. Okay, so if we have a look at this bottom left vertex here, we can see that it has translated 1, 2 squares to the right, and then up 1, 2, 3, 4. And so there's moving right and up 4, and its new location is right here. And if we do the same thing to the top vertex and the right vertex here, we'll go over 2 and up 4. There's our new location, and then over 2 and up 4. So every single one of our vertices on this triangle here has moved the exact same amount, same direction, same distance, right? And that gives us an image that looks identical in shape, it's identical in size, it's identical in orientation, meaning that it's still going horizontally. The triangle is still oriented horizontally across my page. The only difference here is that it's in a new location. All right, so that's an awfully long explanation of what a translation is. Let's just get into the good stuff here, all right? So this example says translate this quadrilateral up 3 and to the left 4. Okay, so the first step is we always want to leave our original object in place because if you lose track of your counting or whatever, it's always just good to be able to refer back to this to know where our starting point was. So that being said, what I'm going to do here is I'm just going to create a duplicate of that original object, which is now my image. All right, so you can see still got my blue one in its original shape. I've just created a duplicate of that, which is the one that I'm going to be moving around from here. So we want to move that up 3 and to the left 4. And that's going to look like this. If we take a look at this top left vertex here, and we count up 3, 1, 2, 3, and then to the left 4, 1, 2, 3, 4, we end up with my upper left vertex on the duplicated image here, all right? We can do the same. We can kind of just double check all of our vertices here and make sure that they're all up 3 and to the left 4 from the original points as well. The other thing you could do, and in my opinion, this is actually a little bit more efficient use of your time, is if you just map out one of the vertices here, so that make sure that the top left vertex is up 3 and to the right 4, rather than recounting it out all over again for the other 3 vertices of our rectangle. It's probably just the easiest to start at our starting point here and then just recognize that our original rectangle was 3 squares wide and 2 squares tall, and then we can just confirm it that way, which is much easier than counting 3 additional vertices. Okay, so that's example one. Let's just have a look at one more example here. Here's my starting object. It is 1 wide and 4 tall, and it's the question here is asking us to translate this quadrilateral down 6 and to the right 10. Okay, so again, we're going to leave our original blue shape in place there. We're going to create a duplicate of it, and then we're just going to make sure that we count down 6. 1, 2, 3, 4, 5, 6. And then we're going to go to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I just leave my cursor there, then when I move the orange image, then the top left corner of it should line up right here with my cursor. So let's just have a look here. Yep, that's exactly what happened. Okay, so we've just effectively translated our rectangle to a new location. Same orientation, it's still upright or vertical. It's still the same size, it's still the same shape. It's only got a new location. There's your lesson for today.